Questions on the homework? Questions on any of the homework so far? I think maybe a half. Yeah. Because for the most part, if it's at least half wrong, then I'll take half. But if it's, I don't normally do a full point unless it's completely wrong. And I don't like doing quarters or thirds or whatnot. The only way I'll do a quarter is if, like, well, it's just I have a, on my physical grade book, I have a box and doing the 0.25. It's too small to do that, and I don't want to increase the box size. But I'll do a fourth every now and then, but it's because, well, two of them, like say you got the signs wrong, but like on last one, but you got everything else right, a fourth and a fourth. So if it adds up to a half, or then I'll do it that way. Or it's not so much, it's a constant error, not enough to do a half, but it does add up. But if you do have questions on how something's graded, always ask. I'll explain it.
Is this what we need to write down for the theorem part right here?
Yes. So you don't have to write the whole thing. So if a polynomial function with real coefficients and a plus bi is a solution, then a minus bi is also a solution. Complex conjugates. A plus bi conjugate is a minus bi. Those are the conjugates. And really the complex conjugate theorem states if a plus bi is a solution, a minus bi is one also. So if we have an imaginary solution, a solution with I, we're going to have its positive and negative case. We have to have it. They always come in pairs. They always come in pairs. And the same thing is true with radicals. If you've noticed so far, if we had, say, the square root of 2 as a solution, negative square root of 2 is also a solution. They always come in pairs. So if we have one, we have to have the other. Now, one of the nice things about both of those theorems is that if we graph, or we're solving and we find that x equals 2 as a solution, it means the other one has to be rational if there's two of them. Because if one of them's a real number, the other has to be a real number. Because again, our irrational, our imaginary solutions, our complex solutions always come in pairs. We'll never have just one. You can, you don't necessarily need it. I would, well, you can get one here in a little bit. Let's look at this first. So we good with this here, complex conjugates. So a plus bi's conjugate is a minus bi. So 7 minus I.
What's the definition of the word
Conjugate. I do not know. I'd have to look that up. Because complex conjugates.
I have no idea what it means.
Because I know what it means in terms of this. But that is a good question.
The only thing I can think of is substitute. I don't know what that is.
I know they conjugate nouns here and there.
Yes.
And all they do is
Yes. And I think that might have part of it.
something like that. We just make the sentence a negative. Like it says they have a dog, say I don't have a dog.
Conjugate. Conjugate. Something's conjugate, a product of conjugating, or conjugate, to give in prescribed order the variation or various inflection forms of, to become joined together, to pair and fuse in conjugation, to pair in synapses. So changing the verb tense is to conjugate, or here a conjugate pair, a complex conjugate is its opposite, so it's going to make it whole. So here, if we look at the first one, 7 minus I, the complex conjugate of it would be 7 plus I. Yeah, the complex conjugate is 7 plus I. Because if A plus BI is a solution, A minus BI is a solution.
So basically, for any of us, kind of just switching the thing, or at least for the basic,
Yeah, part of it. So part of it is this.
from like 1 to 8.
So
Yeah.
you just change the.
So we're changing the sign in front of I.
So with the second thing, A to the I plus II, like any difference? You don't put a negative sign in front of the 7 to push the.
Yep. Because this is really just going off the fact that A plus BI's conjugate is A minus BI. Okay. So I think for the most part, y'all are able to get the rest of these here. Now, before we move on, I want to do something with the first one here. I'm going to take 7 minus I and multiply it by 7 plus I. I'm going to take the two conjugates, the two complex conjugates, and we're going to multiply them together. I would, because there is something that interesting that does happen. Because if I distribute the 7, 7 times 7 is 49. 7 times I is going to be plus 7i. Negative I times 7 is negative 7i. And negative I times I is negative I squared. So I think we're good with that so far, because this is some of what we did yesterday. We're just multiplying it out. Now, if we combine like terms, 7i minus 7i is 0. They're gone. And I squared is negative 1. So I would be the square root of negative 1. Yeah, so really the I squared, we got rid of I, negative. Because our negative 1 makes it plus 1, so we get 50. So that's what's interesting about this here, is because if we take the two complex conjugates and multiply them together, we simplify I out completely. This is part of the reason they always come in pairs.
That's the first one.
Yes, and that's why they work out nicely. Because when we have solutions, and all the equations we've had that did not have real solutions, if you notice, any of those did not have I in them. So we have to have these pairs so that I simplifies out. And it works like this every single time. Because negative 5 minus 5i times negative 5 plus 5i. If we multiply these together, the i's will simplify out. Because negative 5 times negative 5 is going to be 25. Negative 5 times negative 5i is negative 25i. Negative 5i times negative 5 is plus 25i. And negative 5i times 5i is negative 25i squared. And again, just like the last one, our middle terms simplify to 0. I squared is negative 1. Because I is, by definition, the square root of negative 1. I squared is negative 1. Out of all the powers of I, the one that's going to be the most helpful to kind of know or have memorized is I squared as negative 1. Huh? It's easy to remember, and every time it does show up in any step, any process with using I or having to multiply terms together with I, whenever we get I squared, simplifying it to negative 1 and not letting the power get bigger sometimes makes it easier to work with. At this point here, we have 25 plus 25, which is also 50. That's more of a coincidence than anything else.
I was about to say.
No, it's not always going to be 50. It's just going to work out that every single time we do not have I. Multiplying the conjugates together removes I. If we multiply irrational conjugates together, it would remove the radicals, square roots. I have a feeling at this point y'all have already done the rest of these here. Because the complex conjugate of negative 2 plus 4i is negative 2, negative minus 4i. 3 minus 6i is 3 plus 6i.
So, homework, do we have to do like the whole
If it asks for it, then I think the first few do. It asks you to find the complex conjugate and their product. It's asking for both. Mm-hmm. Yep. So, now with the product, like we did yesterday, we can type these into the 84, the graphing calculator, with the parentheses and multiply it. It will multiply those out. 10 minus 2i would be 10 plus 2i. And the last one here, negative 4 plus 8i. 2 more. Negative 4.
plus 3i and 8 plus 3i.
Questions on the first 8 problems? We feel good with those there. Let's add one. What would the complex conjugate of 8i be?
Would it be
Negative 8i. How about the complex conjugate of 7? It does have a complex conjugate. It would be
negative 7? Oh, I was going to say it'd be the same thing then.
7.
When we conjugate it, we put it in front of the one with the I and on the one without it. So.
Because I could say 7 plus 0i. Its complex conjugate would be 7 minus 0i. That kind of makes sense. Now this is a little bit ahead. We'll talk about this again later in chapter 4. The fundamental theorem of algebra says that any solution for any higher degree polynomial function has at least one in the complex plane, complex solutions. I mean, I can write any number as a complex number, 7 plus 0i. Complex number, technically. But dividing complex numbers, we want to write each quotient in standard form. What it means by this here is that a plus bi is what we need it in, and we cannot have I in the bottom of a fraction. So for this here, I'm going to rewrite it so it's a little bit bigger. So we need to rewrite this in standard form, essentially, so we don't have I in the bottom of the fraction. Now,
Could you take it away and put 3i squared?
unfortunately, we can't.
We could put square root.
We're going to multiply this by 1. Well, not just any 1. We're going to multiply by a fancy version of 1.
Fancy version of one?
Mm-hmm.
I don't know there need to be a fancy version of one.
Well, so the issue is with the 1 minus 2i, yes? I need to multiply it by something so that the I goes away. Specifically, we're going to multiply it by 1 plus 2i. I'm going to multiply it by its conjugate. But I can't just multiply the bottom. I also have to multiply the... So we're multiplying the top and bottom by the complex conjugate of the bottom, of the denominator, yes? Well, what is 1 plus 2i divided by 1 plus 2i? Anything divided by itself is not 0, but 1. So really we are multiplying this fraction by a fancy version of 1. So we're going to multiply the top and bottom by this here. So we can think of the parentheses being here. But again, we're just multiplying through. So on top, the first thing we're going to do is 4 times 1, which is 4. 4 times 2i is going to be plus 8i. Thank you. Then we do the same thing with 3i. 3i times 1 is going to be plus 3i. That's fine. And 3i times 2i, 3 times 2 is going to be plus 6i squared. Questions on how we multiplied out the numerator? All right, let's look at the denominator, the bottom. First thing we're going to do is 1 times 1, which is 1. Then 1 times 2i is going to be plus 2i. Negative 2i times 1 is going to be negative 2i. And lastly, negative 2i times 2i is going to be negative 4i squared. So, yes. So the numerator, we are going to combine like terms because our 8i plus 3i is going to be plus 11i. And we're going to replace I squared with negative 1. Or really, what's the I squared doing? It's just changing the sign of the number in front of it. So 4 minus 6 plus 11i. In the denominator, our 2i, negative 2i are going to be 0. And our I squared is going to be negative 1.
I almost suspect.
4 minus 6 is negative 2. So, yes and no. Technically, it's not in standard form. Yeah, because standard form is a plus bi. Now, a and b can be fractions. It technically, I will take that as your answer. Yeah, because really the only thing we have to do to split this apart is because the two fractions are both 5. And the first one would be negative 2/5 plus 11/5 I. This is the technical answer of what they would want. Now, the only way it would really change by breaking it up is if the numerator and denominator had something in common. So if one of the, instead of 11i, it was 15i, 15 over 5 would reduce. Now, sometimes it could be that the entire thing has a common factor and it would reduce down. Sometimes one of them does. Yes. Especially if there's a common factor amongst all three, the top two terms in the bottom. We want to reduce it. Questions on this here?
I understand it, but I don't have a question because I don't know what I don't understand. Yeah, next.
Okay.
I don't even have room for the next one.
What in the world did you do?
Now, luckily, instead of rewriting it again, you can write it next to it or actually do the first step because y'all do have a little, your starting problem's a little bit bigger than this here because really we could start off by just multiplying this by the conjugate of the denominator. which would mean we're multiplying the top and bottom by 2 minus 3i. So on top, we're going to multiply the 1 first. 1 times 2 is 2. 1 times negative 3i is negative 3i. And we're going to do the same thing with negative 4i. Negative 4i times 2 is negative 8i. And negative 4i times negative 3i is going to be plus 12i squared. The denominator, 2 times 2 is 4. 2 times negative 3i would be negative 6i. 3i times 2 is going to be plus 6i. And lastly, 3i times negative 3i would be negative 9i squared. You kind of get how we got to this point here. And really, the way we determine what we're going to multiply it by is just switch the sign in front of I on the bottom of the fraction, and we multiply it by that expression on top and bottom. On top 2, our negative 3i minus 8i is going to be negative 11i plus. Now our I squared is negative 1, so we're going to replace it. 4. In the bottom of a fraction, our negative 6i plus 6i is 0. So that is gone. Minus 9 times negative 1. So our 2 times negative 1 is, well, negative 12. And we're going to have to, I'm just moving it in front of the I term so we have our real numbers next to each other. On bottom, negative 9 times.
How is that? Negative 3, or 2 minus 3i.
Mm-hmm.
How's negative? I thought it was positive. There's a negative in there.
Let's see.
No, look, it would be 1 times.
So, since it's plus on bottom, I see.
That's the top part, though.
Right.
Conjugate.
Conjugate. Yep.
Right.
Mm-hmm. You're good. Sometimes, again, it's that one little sign. You're good. Now on bottom, 4 plus 9 is 13. 2 minus 12 is going to be negative 10. Minus 11i. And if we split this up, it would be negative 10 thirteenths minus 11 thirteenths I. Questions on this here? Over here? So negative 9 times negative 1 would give us a positive. Mm-hmm. Go on and grab a graphing calculator. Doesn't matter which one, just go on and grab one. Well, yeah. Yep. We're just gonna, we'll let it keep going until they are just dead. Go on and grab a different one. Yep. Thank you. Yeah, it could be that one of those batteries is dead or all four are dead. So, get my own note sheet. So we're going to do the last one, the one we just did, before we move on, because we do have the answer for it. So to get a fraction, y'all remember? Alpha, y equals, enter. So we can type the top in, 1 minus 4i over 2 plus 3. Second decimal.
How to do what we just did.
Mm-hmm. Yep. Need one?
She grabbed all of ours and hers.
No, like the fraction.
Alpha, y equals, enter. Mm-hmm. Up at the top. Keep going up. So if you find alpha, go up.
Oh yeah.
Enter.
I had an error. Are you supposed to have glasses?
Yeah, I can see that, and I'm supposed to have glasses.
I have an error. I can see it.
Did y'all get an error?
Yeah.
I don't know. I'm getting there.
I got error data type. One quit, two
Godo, yeah. Got it.
So,
You got an answer.
there's a reason I got an answer. It is because this calculator here is an 84 plus CE, and y'all's are just 84 plus. Yeah. So, yep. Again, most of these calculators from one version to the next have one or two things that are different. This is one of them. Now, let's do this a little different. Parentheses, 1 minus 4i divided by 2 plus 3i. So again, a fraction is just the same as dividing. Division.
Oh, so you can just put it in that way?
Yep.
So clear it or start?
So you can clear it, or you can just go on and type it in on the next line. So we do parentheses, the numerator, the top, close parentheses, divided by parentheses, the bottom, close parentheses. It is going to be important to put parentheses around it, because if you don't, it's mainly just going to divide the here. It'd be the negative 4i divided by 2.
Yeah.
Okay. So we have this here. Okay. So are we all to this point here?
Yeah.
Next thing you're going to do is hit math. So on the screen, it's the button in red. Do you see the math button? It's under alpha. Now the first option there, that arrow FRAC, is fraction. Yep. So if you hit enter, have that selected and hit enter, what that's going to say is take the previous answer and turn it into a fraction. Hit enter again.
Enter on the one.
Yep.
I tried.
Math, enter, enter. Yep, and hit enter. Mm-hmm. Yep.
Wait, what were we supposed to do?
Where you at?
Yep. So type it in.
Oh, I think. I know it. And then,
Then whenever it's like the one.
well, I got an answer, but I typed in the proper one. But I
Yeah.
got.
You typed it in without the parentheses.
No, I typed it in as 2.
2 plus 3i. Yep. Questions on this here? So the calculators can do it.
Mr. McClinton, I don't know what's going on. No, because look.
So right, that's what we started with.
Yeah,
So we don't even need.
Typing in these two?
Yeah.
Okay, that makes sense.
So if you look at the next one on the back, the first one on the back.
Oh, that's the next one.
Yeah.
Oh. That's not fair. I want to see if I can do it. Okay. Wait, and then we I clearly did something. Did you get
Negative 4. 16. What is 8 over 16? Because 8 and 16 have a greatest common factor of 8.
Oh yeah, duh. So you would, okay, divided by 8.
This has a common factor of 4. And we can say 5/4 minus 1/2.
Oh, I got you. I just didn't simplify it all the way.
Yep.
But it is the same thing.
Yeah. I did it. So this is really easy.
Yep. And the main reason we didn't do that first is I want you to be able to see and know how to do it without the calculator before we see the way with it. That's it. And you have